Good morning, everyone, and thank you for tuning into our webinar today on removing the block in blockchain, new solutions that pave the way, organized by SGInnovate and IPOS International. My name is Brian, and for those of you who don't know about us, we are a government-backed investor in Singapore with the mission to build deep tech innovations in AI, blockchain, healthcare, food tech, agri-tech, and more. At SGInnovate, our work involves connecting with the global deep tech ecosystem, working with entrepreneurial scientists to bring their innovative research from lab to market, as well as developing deep tech talent. Today, we have a wonderful series of presentations from our speakers today who will be sharing their insights on the blockchain industry. We would like to encourage our audience here today to share their thoughts on this topic by engaging with our speakers using the Q&A box below. And with no further ado, I will now pass the time for our host today, Ruben, who will get us started. Ruben, please.
Hi, hello, welcome everyone. Thank you for joining us for today's webinar. Now, first and foremost, to those that actually celebrate Lunar New Year, a very happy Lunar New Year to you as well. My name is Ruben from IPOS International, a wholly owned subsidiary of the Intellectual Property Office of Singapore. And our topic for today is removing the block in blockchain, and we'll be shedding some light on this popular yet complex technology. Now, some key points that we want to address today: why blockchain technology has yet to reach its full potential, and what recent patent data reveals about the new solution that would improve blockchain scalability, and how about the latest innovation that can drive blockchain adoption in some of the key industries. Now, allow me to just quickly introduce our speakers to you. Our speakers today hail from our Patent Search and Examination Unit, which reviews new and novel inventions and grants more than 11,000 global patents per year. Our first speaker is Patent Examiner Dr. Teo Ai-Ling, and she specializes in patent applications relating to computer-implemented inventions, including those on blockchain and fintech. And Ai-Ling was also previously on part of our IP strategy solutions team, where she also performed patent data analytics to derive insight for future technology innovation. And our second speaker is Dr. Hong Lei. Dr. Hong Lei is a senior patent examiner, and he specializes in examining patent applications within the information and communications technology space, or commonly known as ICT, with a keen focus on data encryption, blockchain, artificial intelligence, and wireless communication. Just a little housekeeping before we start. May I invite everyone to just put in the questions that you have later into our Q&A panel so that we can moderate from there. And before we start, I just want to get everyone involved, so can I invite Brian to just maybe launch a quick poll? And it's a very simple poll for us to find out more about how much you know about this subject matter. Yes, thank you, Brian. So we have 3 questions here. What is your level of understanding? It's just to give us and also mainly our speakers a chance to have a sense of where your understanding of the subject matter is. And so that this will also guide us later on in our Q&A and how deep we can go into when it comes to explaining some of the questions. Right, can I invite everyone to take your poll, please? And maybe we'll just end off in the next another 10 seconds. All right, Brian, do you think you have the results there? Great. So we have more than half that are new to blockchain. So that's fantastic. So I hope this session, to speakers, Dr. Hong Lei, Dr. Teo, I hope this will be you are actually sharing, you'll be sharing new things with our audience today. Fantastic. Great. All right. Now, without further ado, may I hand it over to Dr. Teo now? Thank you.
So thank you, Ruben, for the kind introduction, and thank you everyone for completing the poll. So it's good that actually most of you are like intermediate or new to blockchain. We will be sharing, so fear not, we'll be sharing some of the basics of blockchain with those. So before we go deeper. So before I go into anything on blockchain, I would just like to show you this chart. Sorry. Okay. Just adjust some stuff. This is actually the price of a Bitcoin over the past 6 years. As you can see, it's going up really quite quickly. So it really just say it's phenomenal. This could be due to the anticipation to use Bitcoin as a hedge against currency. There is also an increasing use of Bitcoins. As we can see, recently I heard news on how it's going to be used in a cafe and even it can be used to buy Tesla car in the future. But we are not here to discuss how to invest in or mine the Bitcoins. Okay, we are here to discuss the technology behind it, that is the blockchain. So today I will be touching on the basics of a blockchain, where they can be used in, and the limitations that prevent blockchain from reaching the mass adoption rate. Hong Lei will then be going through the types of on-chain and non-on-chain solutions that could possibly resolve these limitations and the development rates of these solutions from a patent data perspective. So, what is a blockchain? Okay. First, I would like to say that blockchain is way more than a Bitcoin. So, in fact, I think it is said that the public only view blockchain as Bitcoins or those cryptocurrencies out there. So what blockchain is, it is essentially a database. It is how data is recorded. What makes it different from a traditional database lies in its data structure. So like its name suggests, there are two main characteristics in its structure, the block and the chain. So the block refers to how its data are recorded as blocks, as we can see here in this diagram. So these blocks are usually created on a time basis. The block of data will include the data you want to record, such as a bundle of transactions, for instance, where the Bitcoin is used. On top of that, it will also include these nouns, which is a randomly generated one-time number, and the hashes. So these nouns and the hashes, right, will lead me to the next characteristic of the blockchain, which is the chain part. The blocks are chained together. This is implemented through the cryptography using the hashes that we saw. Let's look at block 2, for example. So as you can see, right, the hash of block 1 is actually embedded into block 2. So the hash of block 1 is combined together with the block data and the nouns to create this hash of the block 2 itself. The block 2 hash is then used for block 3. Then this process will just continue on for all the subsequent blocks. Yeah. This interlink using hashes will create something like a domino effect, like chain letter. So if anyone wants to change a record, it will be difficult because it will just affect the whole chain. So of course, if it's just one chain, you can say, actually it's still quite easy. I just amend the whole chain. But what if this chain is actually recorded in many different independent computers? So this will lead us to the next important feature of a blockchain, which is the decentralized records and verification. So the records, right, are stored in many computers, and to add a new block, it must be verified by many of these computers. So what happens is that when a new block is requested to be added, the request will be sent to this network of computers, or in Bitcoin context, we'll say these are the miners. The computers would then try to solve this mathematical puzzle to guess the nouns that randomly generated one-time number that we saw just now, to produce the correct hash for that block. So when the computer manages to solve the puzzle, the other computers will then try to verify that the solution is correct. So as you can see, there's this chaining effect, there's this involvement of many parties. It makes it really difficult to so-called like play cheat in the system. So this is why blockchain provides this benefit of being tamper-proof and transparent over the traditional databases or transactional systems we have today. So the tamper-proof and transparency benefits does make blockchain attractive for recording data, especially data that is important. As its fundamental use lies in data recording, we can see that it can be applied across many different types of data. In fact, it is way beyond just Bitcoin's transaction. So this will include data that does not change so often. So like the land title, food safety, voting, or patent ownership that we see here over in the blue, in blue color here. And also, this can also include data that changes very often, such as our transactional data, which we can see over in orange here, in the slide here. So I would say that the industries that could adopt blockchain technologies are actually very diverse. You can say it being applied from farming industry to logistic to legal, and of course, our banking and financial industry. So however, if you know, blockchain has been around for pretty some time. In fact, what is for sure is that Satoshi Nakamoto introduced Bitcoin in 2009. And that's when blockchain also start to get garner interest. So 11 years have passed. We do not see any shift in our main transactional channels towards blockchain nor cryptocurrency. So if you look around yourself today, mostly are still using our traditional currency and payment methods, such as credit card. So in a survey, in fact, in this survey conducted by Gartner 2 years ago, only 1% of the 3,000 companies are using or tried to use blockchain. And we only see another 8% who are thinking of using it in the near future. So what this means is that over 90% of the companies are not using blockchain or thinking of using blockchain in this foreseeable future. So this kind of trend actually shows that blockchain technologies are not picked up yet or have not reached mass adoption yet. So what is wrong? Blockchain can provide tamper-proof environment to store your important data, but there's no adoption yet. This could be due to the different limitations we see here. This includes, so there are really quite a number of challenges. The challenges include those from a user perspective, such as the user awareness and knowledge of blockchain. As we can see, about 40% of the audience today is still new to blockchain. So that really signifies our level of user awareness and knowledge of blockchain in current days. And also, people, when they know blockchain, they still think of it as solely just all the Bitcoins, Ethereum, or all the different coins out there. So there's this part about the lack of user awareness and knowledge right now. And besides that, blockchain will also face regulatory control, especially in our financial transaction data. But what we want to discuss today is actually the limitations that lies in the fundamental of the blockchain technology itself. And by this, we mean the throughput and the processing speed of blockchain. The limitations of the blockchain could actually come precisely from how it works to derive all the benefits it provides. So let's use just financial payments as an example. So as you can see on the right of this slide, the traditional payment is pretty much like a linear process. So one could just send a transaction request from the customer to the banks for approval. Then the banks will just go back, send a response back to see whether is it approved. But whereas for blockchain, the verification will have to go through this spider web of computers for this computer to solve this complex mathematical puzzle. So no doubt this solving and this spider web process will take time and a lot of processing efforts. Eventually, this would cause the blockchain to be very slow in processing a transaction and also be very limited in the number of transactions it can approve in a single second. Just to quote an example, Bitcoin processes about only 4.6 transactions per second. So compared to Visa, it handles about 1,700 transactions per second. This is why blockchain needs to be improved in these two aspects, the speed and the throughput rate, before the public are willing to adopt this technology. So Hong Lei will discuss the solutions to overcome these limitations. Over to you, Hong Lei.
Good morning, everyone. Thanks, Eileen, for the sharing of the background of the blockchain. I'm Hong Lei, a senior patent examiner working in IPOS International. In the next session, I would like to talk about the potential solutions to address the throughput and latency problem of blockchains. In order to solve the throughput and latency limitations and promote the mass adoption for blockchain technology, a lot of techniques have been developed in the recent years. And all these techniques can be generally classified into two layers. The first one is on-chain techniques, and the second one is non-on-chain techniques. For the on-chain techniques, it is very straightforward. They focus on the developments on the main chain to improve the scalability. For example, the modifications are conducted within the blockchain per se. On the other hand, the non-on-chain methods aim to shift some burden on the main chain to some off-chain platforms to improve the throughput and the latency issue. For the on-chain techniques, they can be generally classified into 4 categories. In this slide, I will first expand the first two. For the first one, it is related to the block data. That is the manipulation of the block data. For example, the block size can be increased to allow more transactions to be processed. It also comprises the data compression algorithms aiming to increase the efficiency of block size usage by reducing each transaction data size to allow more transactions to be accommodated into a single block. And furthermore, the data storage techniques can also be optimized to reduce the storage overhead to increase the throughput for blockchain. However, there are limitations for these methods. Caps are placed on the number of transactions that can be processed for each block, and the data cannot be compressed to be unlimited small. Secondly, it is related to the different consensus algorithms. As we all know, the typical consensus algorithms for blockchain are based on the proof of work. Under the proof of work, the miners need to solve a very complex mathematical problem in order to generate a new block, which consuming a lot of computational resources. Therefore, in order to speed up the consensus process and improve the scalability of blockchain, different consensus algorithms have been developed, such as dedicated proof of stake or hybrid consensus algorithms, which can combine different consensus protocols, as well as the proof of authority and so on. Thirdly, it is related to blockchain sharding techniques, as shown in this figure on the left. The sharding algorithm divides the large transaction data into different fragments for storage and allows the blockchain to be processed in separate parts, parallel and simultaneously in multiple smaller networks. As shown in this figure, applying the sharding technology is to divide a blockchain network into the several smaller networks into different shards. Transactions in networks will be processed in different shards so that each shard only needs to process a small part of arriving transactions. Different shards can process transactions in parallel, which can boost the concurrency of transaction processing and increase the throughput of the entire network. Fourthly, it is related to the directed acyclic graph, or called DAG. The traditional blockchain stores transactions in blocks that are organized in a single chain structure. With this kind of structure, blocks cannot be generated concurrently. This limits the transaction throughput. In order to solve this problem, an idea dedicated to revising the structure of blockchain called DAG is proposed. Unlike the traditional blockchain with only one single chain, DAG method is designed to generate multiple blocks concurrently, wherein each of the blocks functions as a vertex shown in the figure in a DAG graph, and the different vertices are linked to the previous vertexes. Therefore, a DAG method takes the linear out of the chain and instead replace it with the topological sequence in which each new transaction must be validated by a predetermined number of previous transactions. Therefore, it exponentially improves the speed and efficiencies of the distributed ledger, while resulting more transactions to be included in this system. On the other hand, the non-on-chain methods should aim to shift some burden on the main chain to an off-chain platforms. It can also include 4 main categories. The first one is related to the payment channel. As shown in this figure, the payment channel is a method of reducing the transaction volume in the main chain by temporarily offloading some transactions into the channels, such as the Lightning Network. The payment channel uses a smart contract to enable users to transact without publishing their transactions to the blockchain. It does so by using a software-enforced agreement between 2 participants. It is different from the sidechain, which will be introduced later, because they don't require a separate blockchain to function. Secondly, it is a sidechain. Sidechain is also called a systematic two-way peg system, which includes a parental main chain and a pegged sidechain as shown in this figure on the right. It allows a bidirectional transfer of assets at a fixed rate between the parental main chain and the pegged sidechain. Different from the payment channel on the left, a sidechain is a separate blockchain. However, it is not a standalone platform, as it is pegged in some way to the main chain. The main chain and the sidechain are interoperable, meaning that the assets can flow freely from one to each other. Thirdly, it is off-chain computation. It is very straightforward. Off-chain computation is a system for transferring the complex computation into the off-chain block. After off-chain block conducts the calculation and the verification, the results will send back to the main chain, thus reducing the computational load on the main chain significantly. And fourthly, it is a cross-chain. Cross-chain uses relaying technique to connect the different blockchains to form a big network. The different blockchains are interconnected by the relay chain, wherein a pegged chain is used for bridging the current blockchains to the cross-chain system. The inability of different blockchains to communicate with one another has made it impossible for people to enjoy the full benefits of blockchain technology. Cross-chain technology seeks to solve all these issues by enabling the interoperability between blockchains, thus making it easy for them to communicate with one another and share information. In the following presentation, we have analyzed the global patent data to study the developments and the trends of different on-chain and non-on-chain techniques discussed above. As shown in this figure, it shows the following trends of different on-chain and non-on-chain techniques. In the last 3 years, the patent filing number for the on-chain techniques is about 3,400, while the number for the non-on-chain techniques is about 1,000. The astonishing growth rates of 73.4% and 100.6% in on-chain and non-on-chain technology inventions over the recent 3 years is a testament to the industry commitment to push blockchain technologies towards mass adoption. Both the established digital players such as Alibaba, Tencent, IBM, and some blockchain startups like Hangzhou Fuzanmei Technology are very active in exploring those technologies. We have also divided the patent filing data into different subfields to have a detailed view of the development trend. The x-axis shows a falling trend of different technology, and the y-axis shows the percentage of academia involvement. The bubble size in the figure represents the number of inventions for each blockchain technique category. Blue bubbles represent an on-chain technique category, while green bubbles represent a non-on-chain technique category. From this figure, we can see that the methods related to consensus network currently dominates, with the size of the bubble is the biggest. Blockchain essentially relies on the consensus made by a network of computers to verify a transaction. However, the consensus mechanism, such as proof of work deployed in the current Bitcoin system, is also one of the major causes that adversely affect the scalability of blockchain. Hence, till date, the key effort in improving blockchain scalability lies in developing different consensus mechanisms, as evident from the 3,400 on-chain and 1,000 non-on-chain inventions shown in the figure. About 2,900 inventions relate to the consensus mechanism. Therefore, undoubtedly, with the industry key interest in developing this field, consensus mechanism will improve the blockchain scalability. Beyond the consensus mechanism, alternative on-chain and non-on-chain techniques are also being explored to address the blockchain scalability issue. Amongst these alternative techniques, non-on-chain techniques observed a higher innovation volume and a growth rate than the on-chain counterparts, which indicates the industry's preference toward developing non-on-chain technologies. This preference comes as no surprise, given that non-on-chain techniques allow blockchain scalability without straining the main chain while maintaining cost efficiency. However, with its current innovation numbers nowhere near the effort expended in consensus mechanism, non-on-chain techniques appear to be the candidate choice as a next push for blockchain scalability. From this figure, we can also see that while most of the non-on-chain and also on-chain techniques developments involves mostly commercial entities, however, developing permanent channels as a supplement to the blockchain has observed a relatively higher participation rate from the academia player. You can see from the figure, the permanent channel, the percentage is over 30%. Such academia presence implies fundamental research being conducted in this area and its potential for augmentation. Appending to the growing industry interest as evidenced from its high growth rate, permanent channel presents as an opportunity head start for blockchain developers to establish or strengthen its presence without any competition from the technology giants. In summary, the pattern-centric analysis provides an insight on blockchain technology's developments, and together with other information sources, enable one to form a holistic assessment and a strategy in exploiting these technologies. The highly secured and decentralized blockchain structure have garnered interest from a wide range of industries. In particular, the financial service industry has spearheaded the adoption of this technology. The on-chain and non-on-chain blockchain techniques play a major role in improving blockchain latency and throughput in processing transactions. The new solutions spell hope that its performance and cost efficiency can match up with the industry needs. Therefore, given the faster development of on-chain and non-on-chain techniques, it is promising that the performance of blockchain would be substantially improved to achieve high scalability and a wide adoption in various industries. That is all for my presentation. Thanks a lot for your time. Now I will pass the sharing to Ruben.
Right, thank you, Dr. Hong Lei. Thank you, Dr. Wai Ling. Now, just bear with me for a while I just share with you some. So what I'll do now is I'll just quickly take you through some resources that we are available in IPOS and IPOS International, so that all our audience can benefit from this. In the meantime, while we will let our speakers take some time to go through the Q&A before I hand that over to them. Now just right between me and you and the Q&A, so let me take this through quickly for you guys. So first and foremost, I just want to share with you some of the initiatives that we have at IPOS. So as mentioned earlier, we are the wholly owned subsidiary of IPOS, and IPOS, being the IP office for Singapore, has been very active in coming up with new initiatives to help enterprises to really get things going with their intangible assets and their IP, so that they can take that to the next level. So for example, we are one of the first IP office to launch an app called IPOS Go. So this is an app that right now you can actually register your trademark in under 10 minutes. And in fact, these services will be expanded since August last year. So feel free to download them and check it out. We have also been launching other initiatives like SG Singapore IP Fast Track. And the whole idea of fast tracking something like that is because we do understand that in a world like IT, where in things like blockchain, fintech, where things are so fast moving, you cannot wait for 3 years, 4 years before your patent get granted. So we do have certain schemes that actually allow certain fields to be fast tracked. And right now, this scheme has actually expanded to all fields already. And so if you qualify for this SP fast track, you can get your patent granted as soon as within 6 months. And we do have other schemes as well that is done from the G2G level to help our patent filers as well as other to actually expedite their whole patent application to be granted within the ASEAN region as well. Next, I'd like to share with you we have this range of 15 business guides that we have prepared for enterprises. These are all free to download, and I strongly encourage everyone to download these documents because they are really, really very easy to read, and they come in different topics. They are topical, and they actually address your concern at different times. And they are actually made with enterprise as a target audience. So they speak your language, they speak business, and they help you to understand how you can use IP at different juncture, at different decision-making point to help you to make certain decisions. At IPOS time, we also have different services as provided. So one of them, we have IP clinic. We used to have an IP legal clinic that is still ongoing, but right now it's currently on recess till mid-2021. So stay tuned for that. So those clinics allow, so if you do face any form of litigation or you have any legal inquiries, you may actually tap on that to find out more. And we also have been promoting very strongly on alternative dispute resolution. So as you can, if you understand about IP litigation, a lot of times, maybe more than 90% of those litigation, all those IP issues do not bring it up to court. A lot of them are actually resolved civilly. And we have been promoting how mediation can actually help you to resolve your disputes. So by mediating, you do not need to shorten the time by a lot more. You don't have to spend enormous legal fees. So do consider this as you venture into your business collaborations. So do think about having mediation as one of the options. We do have a lot of training programs as well. So there's one particular program called Applying IP Fundamentals for Business. So this has been split into 4 modules, namely trademark, copyright, patents, and design. So when they are all modularized, each one's only about 12 hours e-learning plus half a day workshop session. We also have some advisory program called Discover Intangible Asset. Basically, in short, we help companies to understand what exactly are your intangible assets. And because most companies right now build your strength on intangible assets, you don't really have any more warehouses or factories, or what you have maybe could just be a laptop that's considered a hard asset. But what you really have are your data, your trade secrets, your network, and these are things that are in your intangible assets. And if you need help to understand, to help you identify and use them in your business applications, this one project that will be very useful for you. And last but not least, we also offer complimentary IP chat sessions. So if you do have any other questions that you have on intangible asset management, feel free to either scan the QR code or you can just go to our website. There's a link there, and feel free to make an appointment with us. Right, so that will be all. Sorry, last but not least now, ladies and gentlemen, as I mentioned earlier, Dr. Teo and Dr. Hong Lei are both our patent examiners. If you'd like to find out more about the life of patent examiner in IPOS International, feel free to join us for this session tomorrow, where our examiners will give you a sharing of what they do on day-to-day and how is it like being a patent examiner. Okay, so thank you very much for your attention. So right now, let us just go straight into Q&A. Just bear with me. Right, thank you everyone. Now, okay. So panelists, I suppose you guys are ready.
Yes.
Great. Now, I think this session has been fantastic. If I were to just summarize, so Dr. Teo has actually gave us a very broad, open, and easy understanding of what exactly blockchain is about, and I think that will be very helpful for 50% of our attendees who are new to blockchain. And at the same time, Dr. Hong Lei has gone in depth to really address some technical things about blockchain, as well as some in using pattern to shed some light on where exactly this trend is heading to. And I think that will appeal to the other 50% who are more familiar with blockchain. And I really thank our speakers, for giving such a comprehensive session today. Now, back to our Q&A, I will take on some of those questions that has been liked by some of the audience as well. Okay, so for a start, I have a question from Chu, and Chu shared this. Would quantum computing pose a threat, a risk to cryptocurrencies? Are cryptocurrencies, for example, like Bitcoin, considered not eco-friendly and not an efficient means of transfer, as commented by Janet Yellen, which is the Secretary of US Treasury? Who would like to take this question? Hong Lei or Hai-Ling?
I can answer this question. Thanks, Chu, for answering this question. Yeah, currently the quantum computing is also asked together with this blockchain, because blockchain rely on the consensus algorithm like the proof of work, which take a lot of computational resources to increase the security of blockchain. While quantum computing, it is a destructive technology which has a very powerful computing power, which can easily solve this proof of work mathematical issues. So people will ask, will the quantum computing pose a risk for the security for this blockchain? Thanks for this question. Actually, from my understanding, the quantum computing is just at its starting stage. It is also has quite a long way to go to replace the traditional computers. Maybe the decades need to develop for this technology. On the other hand, the blockchain is also developing. It also develops other security mechanisms to promote the security. Both technology can develop concurrently. No one knows, maybe in the near future, blockchain can use some techniques in the quantum computing to increase security for blockchain. So yeah, I think both of these two technologies can develop quite well in the future. Yeah, both have very bright future. Yeah.
All right, thank you. Thanks, Hong Lei. Hai-Ling, do you have anything to add for this? Or are you okay?
Yeah, okay.
All right. Now, next one, we have a question from Gui. So of course, Gui will extend his appreciation for the session, and he's new to blockchain. So this one has garnered three responses. Wondering how blockchain can be used for sustainability efforts. So, for example, protection of environment or service industries such as tourism and aviation. So this question really goes into the application itself and some of the industry. Maybe can I invite Hai-Ling to take this?
Yeah. Okay. So as mentioned in the presentation just now, right, blockchain is really about recording the data and important data. So for instance, one thing to think is, so what kind of data will we want to track or audit in the future with regards to sustainability efforts? So one thing I can think right now offhand is like our carbon footprint. For instance, the level of carbon emissions that we have in the different countries. I think that is one possible way. Another way could be tracking about the different materials for recycling or whatnot. So it's really about recording this data and see where this material goes to thereafter. So for the service industry, we can definitely track, like for instance, the booking. But of course, I have to make a disclaimer, all this comes with a cost, so you have to balance out. Okay. So one kind of service industry that I think people are talking about is actually the education. So education, like education records, you want to make sure someone that you hire, the qualifications of that person you hire is actually, should I say, legit, it's authentic. This is when blockchain can come in. So you can just go to the blockchain, and with blockchain, if you can retrieve the record of the blockchain, I think you can say for right now, it's quite certain that that's actually legit. Yeah, so for aviation, I guess maybe the supply of different parts also. So these are just some stuff that, so start thinking from which are the records, data that you want to make sure that it's not, it's tamper-proof. You do not want people to tamper with. Yeah.
Right, thanks, Eileen. Eileen, on that note, I do have a follow-up question from Gary. So Gary did also address this question to you because you mentioned that blockchain is essentially a database. So is it then correct to say that it is similar comparison to software like SQL, Oracle, or SAP DB?
I mean, like SQL, all this kind of stuff are different ways to record your data. Yeah, but I think the difference is like the structure. So SQL, they work off more like relationship management kind of stuff. So it's really about how, okay, so, and because of how it's structured for blockchain, it's structured more like in blocks. Then the different blocks are actually linked to each other. So it's difficult for one to change a record. So this is to ensure, it's really to ensure the integrity. But SQL's, this kind of database, if I'm not wrong, it's more like churning out like analytics. So it's for different use, I would say so. Yeah.
Right. Thank you. Thanks for that. Hong Lei, is there anything you'd like to add for this?
No,
you okay? All right. Now let's go on to the next question from Anxiang. So specifically to alternative consensus methods like Ethereum, for example, was planned to move on to a proof of stake model 3 years ago. Yet 3 years later, they are yet to implement any proof of stake as their consensus method. So his question is, in your opinion, what are the major roadblocks preventing the adoption of more widespread adoption of other consensus methods other than the POW?
I can answer this question.
Sure.
Thank you, Juan, for your question. Actually, for your question, currently in the blockchain technology, there are tri-dilemma exist. Actually, the decentralized and the security and the scalability cannot coexist perfectly. So that's why currently the consensus mechanism is mainly focused on the proof of work. It is more secure than the proof of stake. For the proof of stake, because only a dedicated users or nodes are selected to do the consensus or do the verification. So it is the system is sacrifice the decentralization. It's like a centralized nodes that will do the verification. So the whole blockchain industry are still work very hard to achieve a very good balance of to optimize decentralized security and scalability. Yeah, so the power of stake, the mechanism is also being exploited to further, like some dedicated power of stake mechanism, some involvement from the traditional proof of stake mechanism also being developed. But currently there has not reached an optimum solution for this consensus mechanism. Yeah, the researchers are also work quite hard to achieve this balance of these three factors: the decentralized security and the scalability.
Sorry, thank you very much. Thanks for that sharing. Now, jumping on to the next question, I think we have a lot of questions, so bear with me, panelists, as I go through them. This one has garnered one like from one support. How does from H.E. Chen? How does validation actually work, and what if someone broadcasts a fake record?
Okay, I can also answer this question. Eileen, can you please share the notes of the blockchain?
Okay. Which one?
I think the page 3.
The various blocks.
Yeah.
Okay, let me just.
For the validation of the blocks, actually it is a different consensus mechanism. the most commonly known mechanism is Pave work. It is to solve a very complex mathematical problems, and other consensus methods like a proof of stake, dedicated group of nodes are selected to do the verification. I think the previous slides. Yeah, this one. No. This one. I will use these slides to give a short explanation on how to do the proof of work, the most commonly used consensus mechanism. So, for example, as block 2, if we want to add this block 2 data into this block, so because for the blockchain system, there is no centralized verification. Everyone need to agree. Then how can achieve everyone agree this transaction? So there's a proof of work process. This process is actually to solve a mathematical problem to get this nonce value. It is based on a hash operation. This operation is very difficult to operate from one side, but it's very easier to verify from the other side. So the miners take the hash of previous block and the current block data. And also there's some requirement for the hash of the current block to solve a very complex mathematical problem to do the verification to achieve this nonce value. And when this nonce value is calculated by the miner, then other users can easily use this nonce value to do the hash, to do the verification. Yeah, so that is how the blockchain do the verification. And you also asked if someone broadcasts a fake records. Everyone can broadcast the records, but all these records need to be verified. So to achieve the consensus, meaning more than 51% of the nodes in the system agree your transaction, then your transaction can be included in the record in the blockchain system. If you broadcast a fake one, no consensus achieved, then your transaction will not be recorded in the system. Thank you.
All right, thank you. Thanks, Honglei. So Honglei, you have actually also conveniently answered Gui's next question, which is then what if the block has unknowingly been storing or verifying fake record? But as you have rightfully mentioned, there needs to be a consensus, and there must be at least more than half. You mentioned 51% for it to go through, and there's a lot of background there. So in that, if I were to take on to the next question by Anxian, well, Anxian is asking very good questions since this question has been getting all the likes. But this one, let me direct it to Eiling. I think it's more like a follow-up. You may have already answered this earlier because he asked, out of curiosity, just 1 second, the question just left. Sorry. So he asked, out of curiosity, are there any more interesting or unexpected potential use of blockchain technology that you see beyond fintech or logistics? And Eiling has earlier mentioned education, in terms of verifying the trainers and things like that. So Eileen, do you have anything else to add on top of that?
Maybe one thing to add is actually beyond all this really user transaction or commerce wise, right? Actually, it can also be used in the government stuff, such as voting. So people also use to track the votes and audit. And I think IBM has also used create a blockchain platform for storing your identities. So right now we see people's identities being stolen. You see fake friends on Facebook, right? Yeah. So IBM has such a blockchain platform to manage the identities of individuals. Yeah. So I think that's one thing.
Thanks, Eileen. So if I were to summarize that, I guess the use of blockchain is really more of a horizontal where it can be applied in almost any industry, but specifically the user that just need to identify what exactly is the kind of data that or the kind of transactions that they needed to be secured before blockchain can be adapted. Is that correct?
Yeah, I would say so too.
Right, thank you. Thanks for that. Now we have one more question from Constance, and this one's interesting. She mentioned about WIPO proof. So could you explain briefly on blockchain use at WIPO for its WIPO proof, a trusted digital evidence?
I think for For this, WIPO proof as a trusted digital evidence for blockchain. Because for every transaction you recorded in the blockchain, there's a timestamp associated with the transaction. So for WIPO proof, when you submit the document to the WIPO, the timing of this transaction or document submitted will be recorded, because the time for some document such as priority date or amendment date is quite important. So such a record of this timestamp for this document can be used as a strong evidence to prove the time when the document is submitted.
Great, thanks. Thank you, Dr. Hong Lei. Now, to everyone, we have about another 10 more minutes. So bear with us as we try to go through all your very interesting questions, and so that we can have this sharing more interactive. I have one more question from Jonathan. Is there a way to integrate the use of computing power for other efforts? So for example, computer aid drug development, or can the computation only be used for nonce calculation?
Maybe I'll take that first.
Sure.
Only
Thanks,
can just
Ali.
add on later. Frankly, the computing power, I think you can use it for other efforts. But the thing is also that will be at the expense of the speed of the verification, so of the new block to be added. So there's a balance needed. So what happens in our Bitcoins miners, right, is they tend to use a very specialized processor. So this processor is really just very targeted to mine the coins or to verify our Bitcoin's transaction. That's why you don't see these computers really being used for other users, like maybe your simulation or whatnot. So it's really a balance between your verification speed in blockchain and your other users if you want. Yeah, only if you want to add on.
No, all good? Right. Hong Lei, you okay?
Okay.
All right. Okay. So one more question from Sylvia, and interestingly, from the examiner standpoint, which is both of your standpoints. So based on all the patterns that you have been assessing, and from the readings that you have got, from the examiner standpoint, and in view of the current regulations and governance, where do you see as the most promising application of VCN that can be widely adopted in the industry in the near future?
Manny, what is a BCN?
I'm assuming that you meant Bitcoin, or is there
blockchain?
Sylvia? Or blockchain, yeah.
Maybe blockchain. Okay.
So I guess this is a very similar question to where Eileen has shared earlier. So I guess if I were to recap again, this is as we summarized it earlier, it is really a tool that you can really use it to, and it really boils down to your exact purpose and functions that you have in mind, and blockchain will be able to adapt it, but it always boils down to a cost-benefit analysis, because there are costs involved, as Dr. Teo has rightfully pointed out.
Yeah.
Right.
So, okay, I think I must make a disclaimer, because this does not represent any views of the company or whatnot. Yeah, but right now, a lot of applications or users are geared towards our financial stuff, as we can see in cryptocurrencies, right? So, but I feel that will make the regulation restriction, because it's a currency, it's a monetary kind of exchange. So this will be, so it depends on how the different countries decide to regulate, let's say Bitcoins, for instance. So they may hit a bottleneck there, but others aside, so if you want to use it in other applications, there will be this cost also. So you have to see, so let's say technologies has actually reduced this cost factor. Cost is no longer a concern. I feel that logistics may be able to pick up blockchain quite well, yeah, to manage, to track where its goods are delivered to, or like the authenticity of the goods that you purchase or whatnot. Yeah. So there's, yeah, indeed, there's this regulation and there's this cost involved in the technology concern. Yeah.
Thanks, Alex. Thanks for
Yeah.
Alex. Thanks for making it even clearer for the explanation. Now, Brian, sorry, ladies and gentlemen, at this point in time, we do have time for 2 more questions. But in the meantime, can I request Brian to just share a poll with everyone at the same time, because we would like to gather your feedback about how you feel about our session that we've organized so far. So please take your time to share your feedback with us, because it really helps us to improve our session going forward. Okay, now, and also at this point, I'd like to take 2 more questions. One from, let me just put it out. I have one from Walter. So, okay, so I want from Walter, and perhaps maybe either of you can try to take this. There is a plethora of Me Too cryptocurrencies that have emerged in the past 2-3 years. Do you think this trend would harm blockchain's adoption? Because I think, as where it's coming from, most laymen like myself, will be more, instead of blockchain, we are more concerned about cryptocurrencies. So, but then, and now there's so many, not just only Bitcoin and Ethereum, but there are also a lot of other coins right now, and a lot of other coins exchange. So do you think this trend would actually harm blockchain's adoption? Or you think you actually support on the other end?
I think for the blockchain, I answer first, maybe Eddie can add later. Yeah. For the blockchain, it actually has a lot of applications, as just explained by Eddie. Currently, because Bitcoin, the price is very high. It take a lot of eyeball from the people. So people think the Bitcoin is a blockchain. Actually, the blockchain is much more than the Bitcoin. The blockchain technology per se is also evolving. Also, as shown in our patent data, the development trend for the blockchain is also quite high in the recent 3 years. It is not affected by this negative effect from the Bitcoin. And although the patent filing number is increasing, I think the industry still has confidence to improve this technology. I think in the near future, when the scalability and security issue is improved, I think more industry can adopt this blockchain technology instead of just in the Bitcoin, these different currencies. Eileen, you may add some more points.
Yeah, I think I agree with Hong Lei. So blockchain is way more than cryptocurrency. So the number of cryptocurrencies coming up, right? I do not think it will harm the blockchain, the overall technology's adoption, because it can be used in other stuff. But let's say if it's talking about Bitcoin's adoption, yeah, I think that's this, we have to think about, whether, I think it's the interoperability of the currencies.
Yes, that's right. So I mean, ultimately, there's 2 different currencies going on, and they are all digital based. And how do you actually use Bitcoin and Ethereum interchangeably, and what's the exchange rate? I hear you. Now, thank you, speakers. I have one last question for everyone. I am so sorry to all our audiences that if we have not been able to answer all your questions in view of time. If you do have any burning questions, please feel free to drop us a note to either SGInnovate or ourselves, and then we will be happy to address them outside this webinar. So one last question from we again, as I'm just going through down the list. Roughly how long? So this is more of a technical question. Roughly how long do you anticipate is needed before the throughput or processing speed can be overcome, and at what cost? An example, how long before it becomes more competitive with the traditional mediums?
I think it is very difficult to give the exact time for how does the industry can solve this problem for this throughput and latency issues. But the whole industry is now working very hard to develop many technology like this on-chain and non-on-chain to address this or overcome some shortcomings of this throughput and latency issues. I cannot give you a guaranteed answer of how many years, but there's a bright future considering this faster development. Maybe several years later or 10 years later, the whole industry can solve this issue.
Right. Eileen, do you have anything else to add?
No.
Right. Okay, thank you everyone. We have come to the end of today's session. I genuinely hope that the sharing from our very esteemed and experienced speakers have given you a very good understanding of what this whole session is on, what this blockchain is all about. And I would like to take this chance to thank our speakers and for their time to prepare this and also take this to share with everyone. Now, maybe allow me to hand it over to Brian for the closing.
Okay, thanks, Ruben. So I'd like to thank all our speakers today, Hong Lei and Ai Ling, as well as our wonderful moderator today, Ruben, for sharing their valuable insight and knowledge today. So for our audience, do take note that we'll be sending out a post-event email with important information, including a recording for this webinar sometime after this event. So do keep an eye out for that. So, and with that, we've come to the end of our webinar today. Thank you for spending your Wednesday morning with us. And on behalf of SGInnovate, I would like to wish you all a great week ahead. And we look forward to seeing you again at our next event. Bye.
Thank you.
Bye.
Bye-bye.